and welcome to Atomic Structure GCSE exam questions. So all the questions on this video are taken from real exams, so past exam papers for GCSE. So let's start here. So they're all taking different papers, so you might see different numbers at the top, but they're taking different papers, and you'll see some that are similar that come up all the time. Okay, so chlorine has an atomic number of 17. Figure 3 shows the arrangement of electrons in an atom of chlorine. What is the electronic configuration of this atom? So the electronic configuration is how the electrons are arranged. There's two, so it starts from the middle outwards. There's two. Oh, let me just check, turn my pen on there. Okay, so, oh yeah, it's working. So 2. And then we count the other ones. So 1, 2, 3, 4, 5, 6, 7, 8, 2, 8. So we're going out, and then we're out to the outer shell. 1, 2, 3, 4, 5, 6, 7. 2, 8. Somebody see a comma, somebody see a dot. 2, 8, 7. Okay. Explain using figure 3 why chlorine belongs to group 7 of the periodic table. So this is actually more straightforward than people think. So the group that the element belongs in is just the number of electrons in the outer shell. So chlorine has 7 electrons in its outer shell. 7 electrons in its outer shell. So it's true for all elements. How many electrons are in the outer shell is what group they're in. If it's a transition metal, that's a bit different, but we don't talk about those in terms of groups to say the transition metal, because they can change. So yes, the truth of that is that they can change, but things like chlorine, oxygen, all the ones that are in groups, they don't change, and however many electrons in their outer shell is what group they're in. Okay, the nucleus of an atom is made up of protons and neutrons. Atoms of chlorine contain 17 protons. Figure 4 shows some information about a proton, a neutron, and an electron. We've got proton relative mass 1, relative charge +1, neutron relative mass 1, relative charge 0, electron relative mass very small, relative charge -1. Explain using the information in figure 3 and figure 4 why atoms of chlorine have no overall charge. Okay, so we're told here is that chlorine contains 17 protons. So first of all, chlorine, so neutrons do not get involved in this because they have no charge. Well, they're 0 charge. Chlorine has 17 positively charged protons. Okay, chlorine has 17 positively charged protons, but it also has 17 negatively charged electrons. So if you have +17 -17 equals 0. So the charges cancel out to 0. Okay. Atoms of chlorine 37 have a mass number of 37. Calculate the number of neutrons in atoms of chlorine 37. So the mass is the protons plus neutrons. Okay, so protons plus neutrons. So the mass is 37. Now we know, so the proton 17 plus something. So we have to do 37 minus 17. Okay, so take 7 off, becomes 30, so 20 neutrons. So 20. There are two isotopes of chlorine, chlorine 35 and chlorine 37. Explain the meaning of the term isotopes. Okay, so isotopes are atoms of the same element, so here it's chlorine, that have the same number of protons, but different numbers of neutrons. Okay, so that's what an isotope is. So in figure 1, the letters A, E, G, J, X, and Z show the positions of 6 elements in the periodic table. These letters are not the symbols of the atoms of these elements. Using the letters that we've been given, give the letters of 2 elements that are non-metals. Okay, so if you remember that there is a step going down here, it separates the metals and the non-metals. So most elements in the periodic table are actually metals. So this side, metals. This side of the step, non-metals. So 2 elements, so you've got G and X on this side. Give the letters of 2 elements in period 2. Okay, this is where people might get confused because these numbers at the top are groups. Okay, the groups go down, periods go across, and actually sneaky up is a hydrogen and helium are actually period 1. So period is actually how many shells they have. So this is period 2. A lot of people would get that mixed up with group. So you could have A and E. Give the letter element that normally forms an ion with a charge of +1. Okay, so these would be group 1. So you could have A or J. So you only have to put 1. Don't worry about using the same one again twice. It doesn't say you can't use the same one twice. Okay, you could have put J there as well, because that's group 1. Element E has an atomic number of 5. In a sample of E, there are 2 isotopes. One isotope has a mass number of 10, and the other isotope has a mass number of 11. So it's the same question again. So it popped up in a different exam, and just asked in a different way. Explain in terms of subatomic particles what is meant by the term isotope. So we've just talked about that. So we're just going to do it quickly for 2 marks. So subatomic particles means you have to mention the neutrons. We did before anyway, but this one's asking specifically for it. Okay, so you have to specifically put this. So again, we have atoms of the same element. The same element with the same number of protons. But different numbers of neutrons. Okay, I've had that before. All atoms of element E in this sample contain, let's go back and have a look. Element E has an atomic number of 5. The atomic number is how many protons? So atomic number is the number of protons. So 5 protons. Okay, this is to catch people out there, that one. Element X has an atomic number of 18. State the electronic configuration of an atom of element X. So remember, the first shell holds 2, second shell holds 8. So 2, 8, so that's 10 so far. We need another 8, 2, 8, 8. Okay, let's look back at X. So X is, if it's got a 4 outer shell like that, it's a noble gas. So they could ask that. What type of element is element X? And because it's got a 4 outer shell, it will be a noble gas. So it's always good when you're going through papers to think about what they could ask here as well. So I always guess what they could ask in a different paper, because a lot of the time they ask similar things, but they're all differently asked. So there could be extra things in there. Okay, there is perfectly fine to ask you what type of element that is, or what group it's in. So you can say group 0, group 8. They're both correct. So in an experiment, 3.5 grams of element A reacted with 4 grams of element G to form a compound. Calculate the empirical formula of this compound. So we've got relative mass A and G16. You must show you're working. Okay, so this isn't going to be too difficult. So you sort of think about the moles. So the number of moles is the mass in grams. See this come up a lot in quantitative chemistry as well, but it can come up in anything, divided by formula mass or atomic mass, depending on if you've got a molecule or an atom here. So let's have a look at moles of A. So mass, 3.5 grams. Formula or atomic mass, 7. Okay, we don't need a calculator to do that, because we know that's going to be a half. 0.5. Okay, so then moles of, same thing with G. So 16 grams. Oh, no. So it's easy to make mistakes with this. So it's 4 grams over 16. So we know that that's going to be a quarter, so 0.25. So we've got A to, it can be like a ratio. Empirical is like a ratio. So A to G. So we've got 0.5 to 0.25. Right, so we need 1 to something. So I've times both sides by 2. That becomes 1. That becomes 0.5. We don't often deal in fractions with this sort of thing. So let's times it by 2 again to get rid of any fractions. 2 to 1. So we've got, for every 2 A's, we've got 1 G. So the formula would be, empirical formula would be A2 G. I know that's like a kind of a made up letters, but that's what it would be. Okay, so if you're empirical, that's actually how you do it. Okay. Sodium reacts with chlorine to form sodium chloride. The electronic configuration of the sodium atom is 281. And the electronic structure of the chlorine atom, I'm saying that for a reason, the atom quite loudly, 287. Give the electronic configurations of the ions formed. Right, Na+. If it's a plus, the only thing that's lost or gained is electrons. Protons don't really move. Okay, so what has happened to this is it's lost an electron. It's lost one of its negative charges. Okay, so if it's the atom is 281, the ion is just 28, whereas chlorine has gained an electron. So 287, it was before, 288. So they've both got noble gas configuration. So this is from a different paper. Some of the elements in the periodic table are metals. The electronic configuration of a metal, not all metals, just a particular one I've chosen, is 283. Which row shows the group and period of the periodic table where this metal is found? So that's quite good. It's come up again, isn't it? So it's got 3 shells, so it's in period 3. Okay. It's also got 3 in its outer shell. So it's this one, D. Lithium, potassium, and rubidium are alkali metals. Describe what you would see when a small piece of rubidium is dropped onto water. So you may have seen in class lithium and potassium being dropped onto water. So think about what you see. We might have seen it on a video or something, because rubidium is quite hard to get hold of. So you would see the metal would probably float and move about on the surface. Okay, so you also see bubbles or fizzing. And a smoke, which is actually hydrogen. Okay, what you also see is that you'd see a flame. So if you've got potassium, so a flame would also be produced. Because it would be similar to the other alkali metals. If you've got one, so some of the group, so any group, all the reactions are similar. Okay, the electronic configuration of lithium is 2,1. The electronic configuration of potassium is 2,8,8,1. Lithium is less reactive than potassium. Explain in terms of electronic configurations why lithium is less reactive than potassium. So lithium is less reactive. So let's make a note here. So we're already told that. We don't even have to think about that. We know it's less reactive. Okay, so they're both in group 1. So group 1, metals, give, as you say the word donate, or lose, all different words for the same thing. The outermost electron when they react. Okay, so they give the outer one. So the larger the atom is, so potassium is larger than lithium, okay, larger atom potassium larger than lithium, the further away the electron is from the nucleus. And the lower the attraction, because remember the nucleus is positive. Okay, so nucleus positive. Electron is negative. So the electron, the specific, sorry. So the electron, in brackets, are lost more easily. Also, the electrons between the outer shell and the nucleus shield, that's the word, shield the nuclear charge, making the attraction even weaker. Okay, so thank you for listening today. Good luck in your exams and hope to see you in another video in the future. Thank you. Goodbye.